United Kingdom. So, I will place your thank you very much to the chairperson for my introduction. I'm also extremely thankful to the organizers of the conference and all the reviewers for accepting my research work to be presented in this conference. And above all, I'm thankful to all of you who have come here and shown interest in my research work. My name is, as chairman said, Haroon Farooq, and the topic of my research is investigating the power quality of an electrical distribution system stressed by non-linear domestic appliances. First of all, I will discuss the presentation layout. I am going to discuss the background of the project, followed by the experimental set of results, and then the harmonic analysis and results, followed by the calculation of the distortion power and the true power factor, and conclusion in the end. What is power quality? Power quality of a supply can be defined as a set of parameters which ensures the proper operation of the devices being supplied. So why are we concerned about the power quality? In the recent years, there has been induction of the non-linear electronic loads, computers, and all such appliances into the distribution network at a mass scale. So that is why we are very much concerned about the power quality. And also with the economics associated with the power industry. So we are very much concerned about the power quality. Moreover, if we get going a bit further detail, the newer technologies are coming into the system. You see, in developed countries, people are talking about reducing the carbon footprint and the sustainability of the environment. But in the third world countries, people are still dealing with the scarcity of the energy. So to deal with these various issues, the newer technologies like the distributed generation and the electric vehicles, these are coming into the system. So when all these new technologies, the electronic loads are coming into the system, what we need to investigate what their influence will be on the power quality. Now coming more precisely on the harmonic distortion, which is the main area of my research work. When the current drawn during the positive and the negative half cycle of the supply voltage is not same, the harmonic distortion takes place. Or more precisely, we can define it as the generation of the unwanted components as an integer multiple of the fundamental frequency. This is what we call as the harmonic distortion. In the figure, I have represented an example of the harmonic distortion in which a third, fifth, and seventh harmonic are present, and they are being added upon the fundamental frequency of 50 Hz, and then we get a distorted waveform, which ideally should have been a sinusoidal waveform at 50 Hz. But because of these harmonics, it is getting distorted. So, what are the trends of the harmonic distortion? As we discussed, with the newer loads, it is deteriorating. The main cause of the harmonic distortion is the conversion and the inversion phenomena, which is being involved in all the electronic equipment that we are currently using. So when this non-sinusoidal current, this distorted current flows to the system impedance, it also distorts the voltage. So that is where the problem starts. If in my home there is an equipment which is creating the harmonic distortion, my neighbors will feel the influence of it because I am also deteriorating the voltage quality. The entity which we usually use to quantify the harmonic distortion is the total harmonic distortion, and it can be defined as the root mean square of the total harmonic content, the root mean square value of the fundamental quantity, expressed as a percentage of the fundamental. And the other entity which we usually use to quantify the harmonic distortion is the individual harmonic distortion. It could be in the voltage, it could be in the current. So IAC or TAC, these are the universal terms which can be applied to the current as well as the voltage. So individual harmonic distortion can be defined as the ratio of the RMS of the eighth component, that is the harmonic component, the order of the harmonic, to that of the fundamental. So what are the impacts of the harmonic distortion? If the value of the TAC or IAC goes very high, we have several adverse impacts, damaging impacts on the harmonic upon the distribution system, which include overheating and the damage to the nuclear conductors, false stripping of the circuit breakers, false mal-operation of the protective devices, overheating and the premature failure of the distribution transformers. These all such problems, long-term problems, can be attributed towards the harmonic distortion. Also, we can increase in the losses. this equation, it is evident higher the value of the harmonic distortion, higher will be the value of the current flowing through the conductors. So higher the value of the current, higher will be the line losses. Moreover, we know about the skin effect. Skin effect becomes more profound at the higher frequencies. So for the higher components of the harmonics, the value, the skin effect will become more deteriorating. It will like increase the losses into the system. And if we go to that increase in the common losses, the copper losses increase just because of the same reason, because the current increases in the presence of the harmonic distortion. And if you're coming towards the core losses, there are two types of the major core losses. One is the eddy current losses and the hysteresis losses. Both of these losses are directly proportional to the frequency. So with the increasing frequency of the harmonics, the losses, these losses in the core also increase. So now coming to after discussing the project background, now we have concluded that we need to investigate the power quality of the distribution network so that we can come up with a robust design of a distribution network which can embrace the newer technologies in the future more potently. So what we have done in this research project is that we have tried to evaluate the harmonic distortion caused by a personal computer, a laptop, compact fluorescent lamp, that is an energy saving lamp, and a refrigerator, followed by a microwave oven. So we developed experimental setup to investigate the harmonic distortion caused by all these individual appliances, in which we have used a power quality meter which gives us a value of the power factor, and then we have a national instrumentation data acquisition card, and combined with the current probe, we are performing the harmonic analysis, the Fourier analysis of the supply current. And to facilitate the experimentation process, we also developed a virtual instrument in the lab view. Now coming towards